Scientists made a daring announcement, asserting that they have discovered a new planet unlike anything previously known by NASA. Its groundbreaking findings have revealed that this planet is fascinating, not only because of its location and size, but also because it displays light that seems artificial. Are we on the verge of uncovering secrets that could improve our comprehension of the universe? Could this finding indicate the existence of life on other planets? By exploring NASA's amazing discoveries, we will soon discover the truth regarding these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with the mission to explore some of the most fascinating planets and stars in our solar system. Dawn was equipped with 3 ion engines, capable of beginning a journey that began with a 14-month investigation into Vesta, the asteroid that ranks second in size in the asteroid belt. It sent back detailed images and data, revealing Vesta's complex surface and diverse geologic history. After completing its mission at Vesta, Dawn began the second and perhaps most exciting part of its journey, a detailed study of the dwarf planet Ceres. Dawn was able to, due to its ion engines, leave Vesta's orbit and head towards Ceres, something, other than conventional chemical propulsion, would not have allowed. These engines provided a gentle thrust that allowed Dawn to travel a considerable distance and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in the solar system until its 2006 reclassification. With a diameter of approximately 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most fascinating. Because of its unique characteristics, scientists eagerly awaited the first detailed images of this enigmatic world. It was made clear that bright spots were scattered across its surface, especially in a large crater known for its cratering. These shining spots immediately sparked interest and speculation in the scientific community. The best image we had of Ceres before dawn was a blurry, low-resolution image taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the possibility of finally receiving great discoveries was promised at close range. The Dawn mission sought to improve our comprehension of the process by which waters roll in the solar system and the formation of planetary bodies. The bright spots on Ceres, also seen on other asteroids, could be composed of highly reflective material, possibly salts left behind by sublimated water. The discovery suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt liquid water or brine rather than molten rock. But what exactly are these mysterious lights, and what do they reveal about the nature of Ceres? They might also be evidence of something like ongoing geological activity, even more extraordinary. Ceres stands out from other bodies in the asteroid belt because of its size, mass, composition, and the capacity to include water and ice, unlike the usual rocky asteroids. Ceres has a more comet-like composition, suggesting it could reveal more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres at the beginning of 2015, an important step in its preparation to provide the first close-up views of the asteroid belt's largest object. As dawn drew nearer, images of Ceres emerged, increasingly detailed, revealing a world previously shrouded in mystery. The first images showed a cratered surface, indicative of a long history of impacts. What attracted scientists and space enthusiasts' attention were the enigmatic bright spots in the dark, rocky terrain. As the images increased, the scientific community developed theories regarding the nature of these bright spots. Were they patches of ice reflecting sunlight? Or could they be something even more exotic, like mineral deposits? To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity, but a cluster of several distinct spots. The most widely accepted hypothesis was that these were deposits of salt left by the sublimation of water. This suggested that Ceres had, or still has, some form of geological activity capable of transporting brine or water to the surface, where they rapidly evaporate, leaving bright, reflective residues. These findings challenged existing notions about Ceres, painting a picture of a more dynamic and complex world than had been imagined. The possibility of the existence of groundwater or brine pockets could have profound implications for our understanding of the potential for life in our solar system. Ceres is an intriguing dwarf planet, often described as an icy world with a rocky but porous surface. Different from most surfaces that primarily consist of rocks and metals, the Ceres stands out for its unique composition. Its surface is a mixture of water, ice, and hydrated minerals like carbonates and clays, which give it a less dense structure than its rocky neighbors. This Ceres composition suggests that a significant amount of water is present. Its surface layer is rocky but contains ice, is porous, and traps other volatiles, making it more like a comet than an ordinary asteroid. The dwarf planet is thought to have a distinct interior composed of a muddy, ice-rich mantle and a core high in water, which represents approximately 50% of the total volume of the Ceres. The Ceres mantle is probably a mixture of brine and rock, surrounded by a possible core made of denser materials, such as silicates. The presence of a substantial amount of ice and water suggests that the Ceres may have hosted liquid water in the past, particularly if its core was warmed by radioactive decay early in its history. This internal structure distinguishes the Ceres from nearby asteroids and prompts intriguing inquiries about its potential to be the site of geological activity and the role of water in its evolution. Nevertheless, the discovery of ammonia clays on the Ceres suggests that this dwarf planet may have formed in a cooler part of the solar system and then migrated inward when ammonia was present. Ammonia may lower the freezing point of water, supporting the existence of surface brines. These insights into the history and composition of the Ceres not only enhance our understanding of this fascinating dwarf planet, but also provide valuable clues about the processes governing the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, especially compared to the more familiar volcanic activities we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, expel materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments in which the Ceres cryovolcanoes are found. Cryovolcanoes on the Ceres function by allowing water laden with dissolved salt to reach the surface. When the salt water makes contact with the vacuum of space, it rapidly sublimates, going directly from a solid or liquid state to gas. This leaves behind glowing, reflective deposits of salt. These salt residues form the enigmatic bright spots found on the surface of the Ceres. The most famous of these bright spots is in a crater called Air, known as 5. This area has garnered much attention because of its high reflectivity and periodic haze observed by the Dawn spacecraft. These hazes are believed to be caused by water sublimation, which suggests that activity may still be occurring or may have occurred relatively recently on the Ceres. In addition to 5, the Ceres hosts several other positive aspects, each with its own particular features. These locations are not restricted to a single region, but are dispersed all over the surface of the planet-sized dwarf, indicating that cryovolcanism may be a widespread phenomenon on the Ceres. The presence of these shining areas emphasizes the dynamic and active nature of the Ceres, challenging previous assumptions that it was a geologically inactive world. As the Dawn spacecraft provided additional images of the Ceres, a wide variety of surface features began to emerge. The Ceres' surface is dotted with a variety of craters, each telling the story of the dwarf planet's history. As Dawn continued to orbit the Ceres, researchers gained an even deeper understanding of the tiny planet's internal and surface processes. One of the most exciting revelations was the presence of organic molecules, the building blocks of life. In 2017, NASA announced the detection of aliphatic organic compounds in the region around the elaborate crater of Vernite. Carbon-based molecules are frequently associated with biological processes, despite the fact that they can also form through abiotic mechanisms. The presence of organics, coupled with brine deposits and evidence of liquid water in the past or present, suggests that the series may once have had, or still maintains, the conditions necessary for the survival of microbes. While no life has been detected, the convergence of organic chemistry, water, and internal heat makes the series a compelling target for astrobiological research. From a historical and cultural standpoint, the series also holds a special place in astronomical history. It was the first object found in the asteroid belt and was initially categorized as a planet before being redefined as an asteroid and later as a dwarf planet. Its changing status mirrors the evolution of astronomical classification systems and our growing understanding of celestial bodies. From a scientific perspective, the series represents a time capsule from the early solar system. Unlike larger planets that have undergone extensive geological processing, the series has remained relatively unchanged. Studying it offers a window into the conditions that prevailed over 4.5 billion years ago, assisting scientists in developing theories about planetary formation, differentiation, and migration.